Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas and concepts in mathematics, kindergarten through grade 5. Well, you can see in front of me I have some classic board games that you may be playing at home these days, and I want to assure you that whether you're playing Monopoly, or Sorry, Yahtzee, Mastermind, Dominoes, you are indeed focusing on a part of the mathematics curriculum. And I want to talk a little bit in this lesson and the next about what I mean by the process standards versus the content standards in mathematics. Well, the content standards would be what you see in the 5 circles here. The content, depending upon what state you're in, the language might vary just a little bit here, but the content of what we're teaching students would fall in an area called number and operations, or data and statistics, measurement, algebraic reasoning, or geometry. That's the content that we teach, and it's not with the equal emphasis in each one of the grade bands. For instance, number and operation is a large part of what we do at the primary level. Overarching all of this, though, you see are the process standards. Instead of content, we think about the process by which students are learning the mathematics and how they're applying their mathematics. We talk about connections and communication, reasoning, representation, and problem solving. So how do the process standards come out when we're playing some of these board games or card games with students? Well, in front of me, I have a collection of dominoes. It's the small set of dominoes because in my family, I have the large set of dominoes that go from 0 to 12, and it's a pretty intense process when I'm with my siblings or my children and nieces and nephews. We play the classic domino games, and we're all very competitive. But you can use these domino pieces to also reinforce some of the content and process standards here. And I'd like to just do a quick demonstration of that. If you look at a smaller set of dominoes, only 0 through 6 tiles versus 7 through 12, if I lay them out in front here, you can see that they are face up right now, but imagine they were turned over. One of the games that we could play is to turn over 2 at a time and ask, do we have the same sum? And if we do, we get to keep those tiles. If we don't, we turn them back over again. So it's sort of like Go Fish. So if I were to pick up these 2 tiles, I have a sum of 10 on each one of them, so I would keep those 2 and play would continue. Well, certainly the content here, the sums, practicing our sums through, actually because of the 6, our sums through 12, that is part of the content standard. But the process standard, how are we representing the number 5 here? You can see that there are 5 dots. That's actually called subitizing. In kindergarten, we talk about subitizing numbers. Can I look at and immediately recognize the number 5? This is the domino display of the number 5, but you know that I could just put 5 dots in a row in a linear fashion. I might put them in a circular fashion. We want students to be able to look at and immediately recognize a quantity. That's called subitizing. So we're practicing that here. Certainly we are also doing some reasoning, recognizing that a sum of 2, there aren't many possibilities in terms of our tiles here to get a sum of 2. There are many more possibilities to get a sum of 10. So that's a quick one with dominoes. Perhaps you also have darts at home. And certainly if you play the classic 301 or 501 or crickets, all of those involve some of the content standards, some of those numbers and operations. But I'd like to use the context of darts to be able to pose a problem and to really focus on the process, meaning focus on the process of problem solving, to focus on what the reasoning would sound like in solving this problem. So let me pose it to you first. Here's the problem, and it came from the National Council of Teachers of Mathematics, the professional organization which I and most mathematics teachers belong to. There's a dartboard here which has the numbers 15, 16, 17, 18, and 19. And you can see that there's a quick scenario about how you play Darlene's dartboard game. You take turns, you and your partner, and you're trying to get a sum of 100. So that's the problem. Could we play this game with our son or daughter? Certainly, we could practice our addition sums, of course, as we're playing the dart game here. But there are some questions that might arise along the way, some reasoning that I'd want to hear from children as they're working on this problem here. Do I have to use every one of the numbers? Could I use the numbers more than once? Meaning, could I find a solution where 18 is used more than once? I'm wondering if I can indeed get exactly 100. I wonder if there's more than one way to get 100. All of those are questions that we want students to ask as they're working on this problem, because that's part of the reasoning process. So I would encourage you to try this problem with your son or daughter and see what happens. I'd now like to share with you, however, some reasoning that I've heard from students who have tried to solve this problem. Meaning, if we stop playing the game now, playing the game of trying to get the sum of 100 with a partner, and we simply ask the question, how do you get a sum of 100 using those 5 numbers? I'd like to show you some thinking, some reasoning that's gone on with students who have solved this problem. And when students are solving problems, I ask them to think aloud. Talk aloud as you are doing this so that I can hear your reasoning that you're using. So perhaps one of the ways in which students might solve this problem of trying to get 100 using those numbers, the first one is called, let's try one of each number. Let's see what happens if I add up the numbers 15 through 19. And if you do that, you can see that we have a sum of 85. Well, I'm only 15 away now, so I know that if I add 15 more, I would have a sum of 100. So I've used 6 numbers, 15 through 19, plus one more 15, to get an answer of 100. So that's one possibility. Perhaps a student might say, gee, I really like odd numbers, so I'm going to try by adding my 3 odd numbers together, 15 plus 17 plus 19. And I get a sum of 51. Well, that's pretty close to 50, and it's pretty, if I could double it, I would be at 102, but I also know that 15 plus 15 is 30, and so I have 51 plus 30 is 81. Gee, I only need 19 more, and I would be at 100. So again, there's another solution. I've used 15 plus 17 plus 19 plus 15 plus 15 plus 19, and I have an answer of 100. Are there other ways to use those same 5 numbers to get a sum of 100? Well, yes, there is. I've heard a student explain it this way. Laurie, I tried by just adding the first few numbers together, and when I did that, I have a sum of 48. Well, again, that's really close to 50, and 50 is half of 100. So they replaced the number 17 with the number 19, and when they did that, they got a sum of 50. So if I double that, I would have 100. Here are 3 different ways I've seen students solve that problem. That's the problem-solving process, being able to reason about it, practice their number sense, but you can see where these process standards are coming in here. Well, as a nice extension to this, besides playing just the game itself and asking the question, can we get 100? Here are some things that students have posed to me before, or questions that they have asked that I would encourage you to try with your own son or daughter. So how many ways are there, do you think, if I use those numbers to get 100? It's important to know that you don't need to know the answer to that question to ask it. I often ask students questions that I don't necessarily know the answer to, and that's okay. I want them to understand that that's the process of doing mathematics, of being able to tackle a problem. Even when we don't know the answer, we want to just have a strategy for starting it. So it's not important that you know the answer to this question in order to ask it. So are there any answers that didn't use, any solutions that didn't use 6 numbers? Because I noticed all 3 of those samples used exactly 6 numbers. Do you think I could use 7 numbers, 7 of those numbers to get 100? Or could I do it with just 5 numbers? And each one of the samples that I showed you used the number 15. I wonder if there are any solutions that don't use the number 15. To change the problem, an extension to use this same sort of strategy with younger students, just use the single digits, 5, 6, 7, 8, and 9, and change the target to 40 instead of 100. So board games give us the opportunity, when we're playing with our children at home, they give us the opportunity to really focus in on those process standards that are a really important part of the mathematics curriculum. So thank you for being with me. I'll see you next time.